Let's go to question 3. Scientists have developed a corn whose quality may help chickens gain weight faster than the present type used. To test this new type, 20 one-day-old chicks were fed a ration that contained the new corn, while another control group of 20 chicks was fed the ordinary corn. The data below gives the weight gains in grams for each group after 3 weeks. A. The scientists wish to investigate the claim that Group B gained weight faster than Group A. Test this claim at a 5% level of significance, noting which hypothesis test you are using. You may assume that the weight gain for each group is normally distributed, with the same variance and independent from each other. We got to use t-test of the difference of two means. We also assume that the weight gains for each group is normally distributed with the same variance, which means this is a pooled two-sample t-test and independent from each other. We also assume that the samples are selected randomly. Second step, we need to write down HO and H1. Before we write down HO, H1, we need to define the variables. Let mu A be the population mean of the weight gain of group A, mu B for group B. HO will be mu A equals mu B. H1, group B gain weight faster than group A, so mu A less than mu B. We put all data into this spreadsheet. A for group A data, B for group B data. Go to menu, go to 4, go to 4 again. Go to two sample t-test, go to 4. Data input method is data. List 1 is A. List 2 is B. Then for this H1, mu1 less than mu2. Pooled, yes. Okay. So we got this t equals negative 2.46, p-value equals 0.00928, degree of freedom equals 38. Then we can draw the conclusion. Since 0.00928 less than 0.05. Reject HO. Enough evidence to suggest that Group B gained weight faster than Group A. B. The data from the two samples above are combined to form a single set of data. The following frequency table gives the observed frequencies for the combined sample. The data has been divided into 5 intervals. Test at the 5% level whether the combined data can be considered to be a sample from a normal population with a mean of 380. This means we got to use chi-square GOF test. HO, the data can be modeled by normal distribution with 380 and sigma squared. H1, the data cannot be modeled by this normal distribution. Second step, we need to estimate this sigma from the given data, which is this 40 data. Put it into your calculator to get this S sub n minus 1. I put the data, 40 data in this calculator. Then go to menu, go to 4, go to 1, go to 1, enter. X1 list is A. No frequency list. Then enter. You will get this S sub n minus 1, 49.59. So S sub n minus 1 equals 49.59. We need to work out expected frequency now, or expected values. We need to put the normal distribution into graph. It should be y equals norm CDF from negative infinity to x, 380, 49.59. Do not forget times the total number 40. Go to the graph, put in norm CDF, then times 40. Then enter. Go to this scratch pad. Go to variables. Enter. Go back the table. When you check this interval, you could say 310, 311. You need to make this into continuous data. So we will use the average, which is 310.5, to connect these two intervals. In this way, we will get the following intervals. When you work on expected frequency, since the domain for expected frequency is from negative infinity to infinity, make sure you will work on the expected frequency for less than 271 and more than 470. For observed frequency, both are 0. Let's go to, we will put F1 of 271 to get this expected frequency. Variable again, 310.5. Then minus F1 of 271. Enter. $350.5. 310.5. Then enter. Keep going. How to get more than 470? We can use f1 of infinity. Minus f1 of 470 to get the expected frequency for more than 470. Let's record all the data into our table. We will combine groups because some expected frequencies are less than 5. When we add these two, still less than 5. So we need to add these 3 together. When we add these two expected frequencies, the result will be greater than 5. So this is good. In this way, we need to combine this. This is 11. Combine this, it's 6. So we got this is 11.0385. These two adding together will be 6.1702. Then we will put this data into the spreadsheet. Before we do that, let's work out degree of freedom. 1, 2, 3, 4. 4 minus 1 for simple case. Since we estimated this standard deviation, we need to minus 1 again. Degree of freedom is 2. F for observed frequency, FE for expected frequency. Manual 4. Chi-square GOF test, go to 7. Observed frequency is F. Expected least is expected frequency. Degree of freedom is 2. Then enter. So we got chi-square equals 3.47. P-value 0.176. Then we can draw the conclusion. Since 0.176 greater than 0.05, fail to reject HO. Enough evidence to suggest that the data can be modeled by this normal distribution.